In its research center in Nuremberg, Nexans installed a new test center, the Automation Application Center. On an area of 240 square meters, the different bending and torsion movements that energy and data cables have to withstand in praxis are simulated. The Application Center disposes of 4 different testing devices for trailing chain tests. They differ in length from 50 centimeters to 13 meters, and also in speed, acceleration, and bending radius, covering a range of 10 to 300 millimeters. This unique test center, with such a manifold arrangement of equipment, allows an absolutely realistic simulation of movements that automation cables have to withstand in practice. The suitability of applied materials as well as new design elements is evaluated in systematic basic tests in the Nexans Research Center. Therefore, not only mechanical resistance of insulation materials is evaluated, but also resulting electrical properties. Resistivity and electric strength, for example, are directly measured during tests. By the way, requirements are exclusively defined by the customer. There are no official standards for this product group. There are 2 test devices for reversed bending tests in the Automation Application Center. Test results gathered in the Application Center allow well-founded statements on the utilizability of the products. Furthermore, risks and limits can be recognized with the measured data, which is directly transferred into product optimization. On 3 torsion devices, combined torsion and bending tests can be carried out with different torsion angles. Above the permanent testing of our own products, an extensive benchmarking program is carried out and allows a realistic comparison of Nexans special cables with competition. With results from torsion tests, we can evaluate the suitability of potential materials and elements for robot applications. Torsional stress, for example, cannot be compared with the 2-dimensional movement of a trailing chain. The comprehensive knowledge on behavior of different materials and designs is decisive for the marketability of products. Requirements on special cables are enormous. Energy, data, and signals have to be transmitted absolutely reliably, even after millions of movement cycles. This makes highest demands on material and design. The selection of the right materials, design, and construction of energy and data cables requires a high level of material know-how and, of course, a well-founded comprehension of the application. Insulation and sheathing compounds used for automation applications have a decisive influence on flexibility and resistance of cables, as well as their behavior at extreme operating conditions.